In this lesson, we'll cover traffic calming. We'll talk about self-enforcing engineering treatments such as street closures, volume control, and speed control. We won't cover educational and enforcement activities in depth, although these are very important for traffic calming. I'll be approaching this from the highway design perspective. Traffic calming can be done for livability, crime prevention, urban redevelopment, and other reasons. We will talk about how traffic calming is both a means relative to the changes in alignment, immediate ends, which result from reduction in speeds, and then, of course, the ultimate ends, which are safety and livability. Some of the first major traffic calming works were done in the early 1970s in Seattle, and in our state, Charlotte was early into the traffic calming arena in 1978. So let's take a look at an example. This is a street in Raleigh. As you can see, it's a dead-end street, and from the horizontal perspective, you can see there's a curve at the beginning and then a fairly straight road the rest of the way. This is a street-level view of that same road, so you can see a very straight road, as you can imagine, likely to encourage speeding. The city of Raleigh actually did a speed study on this road about halfway down the street. The road has a 25 mile per hour speed limit, and almost 20% of the speeds were more than 5 miles an hour over that speed limit, with the maximum speed actually being 55 miles an hour. And some of those higher speeds were in the evening hours. But one of the big takeaways from this is that if you think about who the people are who are speeding on these roads, this is not cut-through traffic. These are residents. So within a fairly small neighborhood community, most of the people, or probably all of the people who are exceeding the speed limit, are actually people who live on the street. And if those people can't be motivated to maintain safe speeds, to increase safety or increase livability of the street, you can imagine it would be difficult to get other drivers, particularly those just cutting through a neighborhood, to observe safe speeds. And really the heart of this issue is when you look at the relationship between vehicle speed and pedestrian fatality rate. So in the graph on the left, we see the speed of the vehicles moving up in approximately 15 mile per hour increments and the probability of pedestrian death. So at 15 miles per hour, if a pedestrian is struck by a vehicle, there's a very high likelihood of survivability. We move up to 31 miles per hour, and the survivability is just over 60%. The probability of death just under 40%, and then we move up another increment to 44 miles per hour, and the probability of death is now over 80%. So this is really the crux of the issue when we look at traffic calming and the impacts of speeding in relation to pedestrian and vehicle strikes. When we're talking about traffic calming, the state of the practice document from the FHWA and ITE states traffic calming as actions that serve to minimize the undesirable impacts of motor vehicles on local human activities. Accessibility and mobility should not significantly be reduced. So there's a balance here that needs to be struck between the local human activities and then on the vehicle side, accessibility and mobility. So it is a delicate balance, and some places have done this better than others. It's not the same thing as traditional street design, but the goals really are similar. Typically, traffic calming is a retrofit to an existing street, and the programs that address traffic calming can be fairly simple or very diverse. Streets, traffic problems, and neighborhood preferences are not all alike on all streets, and so individual traffic calming treatments must vary accordingly. Programs typically start with one or two of their favorite or preferred measures that have worked well in their communities, and then begin to experiment with others as their favorites may have limitations that become more obvious. The trend is toward diversification. using multiple measures on a single street or at even a single slow point, as we will talk about in the upcoming materials. Early traffic calming programs mostly focused on volume control as a way to control speeds and to improve safety. Now, most traffic calming programs rely on primarily speed control treatments such as humps, circles, and other speed control measures. Communities now express interest in avoiding the diversion of traffic from one local street to another, so we've got to be careful not to fix a speeding or volume problem on one street that then just migrates to the next adjacent street. And also focusing on calming higher order streets where speed controls are acceptable but volume controls would not be. So focusing on limiting speeds on those higher order streets but still maintaining a high volume of traffic that's traveling through the area. One of the big concerns with traffic calming, particularly with speed controls and speed control measures, is the spacing of the slow points, and we'll talk about some of the effects of those spacings through this material. The concept of traffic calming originated in Europe with the idea of slowing traffic on the main route through a small town. Some of these designs that we'll discuss apply to main routes, others to collectors and local streets. The WUNRF is known as a living street and is an idea to calm traffic and to kind of restore the balance between people and automobiles. This is a concept popularized in the Netherlands in the 1970s as a reaction to that dominance of automobiles. The first few years after World War II, Dutch transportation engineers emphasized relocating bikes onto separate paths to accommodate vehicles. This created some backlash, and the country then moved in the opposite direction, where motorists were forced to make accommodations for everyone else. The intent of a WUNRF is not to make cars disappear, but to integrate them and other users of the street into a shared space. In 1976, the first WUNRF appeared in the city of Delft. Actually, a decade earlier, but the traffic regulations came in 1976 and have been used there with success of helping to mix vehicles, pedestrians, and bicyclists. So this is a fairly uncommon type of design to see in the world, but it is being done in the Netherlands and other places. This image is actually from a project in Toronto, waterfront Toronto, that was under construction as of a couple of years ago, so at this point it may be complete. So we need to think about measures of effectiveness when we think about traffic calming. So I've talked about a couple already, primarily volumes, speeds, collisions, but there are others that may be of interest to an agency, including visibility and forgiveness, setting expectancies for all road users. Emergency access is a big one, so making sure that the traffic control, traffic calming measures that are put into place do not unnecessarily restrict access from and to emergency vehicles. Providing space for other users may be a concern. Aesthetics, harmony, and context could be measure of effectiveness, though those may be difficult to measure objectively. You may look at business impacts, the level of rents, house and land prices that may be affected by having higher livability. Noise and air quality may also be important factors for a community. Typically, speeds are the most important when you're dealing with traffic calming, and certainly one of the easiest to measure. Emergency access, though, is a big issue and can be a concern or a roadblock to traffic calming. And when we talk about space for other users, this is primarily relating to pedestrians. And one of the big things when we talk about measures of effectiveness we've got to be careful with our scope and not just look at the particular local road that the treatment is being applied to, but look at adjacent roads and the larger network, because the traffic calming may help one location and hurt other locations on a similar level. It is possible, and many agencies do like to calm traffic with only traffic control devices. Typically, though, many of these are very ineffective, but again, popular, and these include speed limit reductions, two-way stop signs, and multi-way stop signs, particularly in neighborhoods. Most cities have really given up on fighting against stop signs and will essentially install them anywhere neighbors request. And typically these are not enforced vigorously within a neighborhood. And the issue there is that you may encourage drivers not to obey these signs, which then could lead to the larger network. So if they start to see stop signs and speed limit signs more as a suggestion than actually a traffic control device that needs to be respected, that can be a big issue. Some of the traffic control devices that can be effective if they're used appropriately are no turns, one-way streets, and having low progression speeds on a coordinated signal system. So that way, if a driver is driving through multiple successive signals, that the green wave progresses at a low speed, which so encourages drivers not to race to the next signal, but to follow the progression speed. And some agencies actually post the progression speed to help encourage drivers to follow the green wave at a particular speed. Automated speed enforcement also looks promising in terms of a traffic control device. Is being used in limited capacity throughout the United States and more places around the world. There are a variety of design elements, including some that can be lumped into the horizontal elements category and others into the vertical elements category. So in the horizontal elements, we're looking at adjusting the movement of traffic from the left to right, essentially the horizontal direction, and then vertical elements move the vehicle up and down vertically. In terms of street narrowing, so these are primarily horizontal elements. Certain treatments have more or less applicability on the roadway type. Generally, most things can be used on a local street or local road, but then there are some treatments that may not be as applicable to higher order roadways. Here, just continuing this list, looking at some of the horizontal deflection, and in this definition, the profile alterations are what I referred to earlier as vertical elements. So looking at some images of these, the mini roundabout is a potential horizontal design element to calm traffic. Chicanes are also another option, so essentially this is introducing some curvature into an otherwise straight roadway by using bulb outs or extending the curb. This is an example in Adelaide, Australia. It certainly had a significant or substantial effect on drivers. Essentially the road in this area was reduced to one lane through the chicane. And this is just a more close-up view, again discouraging drivers from cutting through on an otherwise straight roadway in between blocks and controlling their speeds there. This is an example in Raleigh on a road that treatment or concrete curb and median was added in the center of the roadway, and also added in some horizontal curvature in this section of road. Mid-block deflection elements can be added. So this is an example from the Massachusetts Highway Design Guide of how these treatments can be installed and their typical dimensions, as well as street furniture that can be added along the edge of the roadway. And so typically from the roadside design perspective, we usually want to have street furniture or objects further back from the roadway, but when they are close, they do encourage drivers to slow down. So there is a kind of a balancing effect that's necessary there to balance the safety effects of potential collisions with these objects with the traffic calming nature of them. A very similar type of design is a choker. So this is just basically squeezing in of the roadway. So if you have a large roadway, particularly one that has on-street parking, if that on-street parking is not commonly utilized, it may be beneficial to add a choker to have that physical narrowing of the roadway at this point. These are also called pinch points, mid-block narrowings, mid-block yield points, constrictions, and maybe other names. Here's an example locally, Kaplan Drive in Raleigh, that has some chokers, again just kind of pinching in or narrowing the roadway at points. Otherwise, the normal cross-section on this road allows for on-street parking, but as you can see in these images, there's not a lot of on-street parking, so there's really typically not much friction that on-street parking provides to the vehicles. And again, some specific design guidance on mid-block street narrowing efforts. You can also do the opposite of a choker, which is putting something in the median of the roadway, but again having the same idea, same concept of just squeezing in, narrowing the lanes, which encourages drivers to slow down. And this treatment was also put in on Kaplan Drive, and you can see in the background of the picture the choker. So again, using multiple treatments to help encourage drivers to slow down, and hopefully their combined effect will decrease the speeds as desired. Here's another example of a median, in this case also affecting the through traffic between side streets, so that can be another thing that could be a benefit to having a median element in the roadway. There are semi-diverters, so this essentially turns streets into one-way streets, or you can have no turns at these locations. So at the end of these side streets, only one-way traffic going out is allowed. The nice thing about this is in an emergency vehicles could still access these streets, so it doesn't completely shut down the street for emergency access, but for normal operations, only one-way traffic is allowed at these locations. You may also have forced turns, so in this picture we see a no left turn at this intersection. These types of islands are also called pork chops because of the shape, or right turn islands, or forced turn channelization. So again, a lot of these treatments may be called different things in different locations or by different agencies. A diagonal diverter, also known as a full diverter or a diagonal road closure, essentially shuts down possible movements in at a four-leg intersection. You may, though, as shown in this image, allow bicyclists to travel in any direction by making part of the area traversable for bicycles. And some of these details again shown here that would allow for a bicycle opening with this type of treatment. A similar concept is the star diverter. So instead of allowing some of the through movements, it basically forces everyone into a right turn at each of the approaches to the intersection. Cul-de-sacs may also be used. Actually, this is a pretty severe design element, so shutting down the street for through traffic. But again, you may allow access through the street for emergency vehicles or for bicycles. Other elements may be specific to parking, again using the on-street parking to help constrict the flow or the speed of traffic. You may use some fixed physical elements to narrow the lane width, narrow the roadway width, Intersections are also an area of concern, a way you can encourage or support pedestrian use by having bulb outs on streets to allow pedestrians to get a little further out into the roadway before they attempt their crossing. This is particularly helpful if there are parked cars adjacent to these locations to allow the pedestrians to be more visible to vehicles and vehicles to be more visible to pedestrians. This is an example of a bulb out at a mid-block location in Cary. So the sidewalk is pushed out to the edge, essentially, of the parking lane to give pedestrians a much narrower crossing to make across the roadway here. There are a lot of vertical design elements as well. It's always interesting to me. Different speed humps have different profiles. It's possible to have some that follow a sine wave or are circular or parabolic or flat topped. And so the next time you drive over a speed bump or a speed hump, see if you can determine which type of design is used. ITE recommends that vertical design elements, particularly bumps and humps, should only be used on local roads, typically should only be on roads with 2 lanes or fewer, and shouldn't be heavy transit, truck, or emergency routes. Speed should be relatively low on those roads, 30 miles per hour or less. It should probably have a speed-related collision problem to put in such an effective and physical element, and shouldn't be near an intersection or a sharp curve, and should also have support from most of the residents. This is an example in Charleston, and a lot of communities either use some variance in the signage or the markings or the texture on their speed bumps or speed humps. This is again on Kaplan Drive. So again, Kaplan Drive has a number of different traffic calming elements that have been applied there. Here's an example of a speed table. Several of these are present on NC State's campus. In a similar type of effect, entire intersections can be raised that will help decrease speeds or calm traffic. These are also known as raised junctions, intersection humps, or plateaus, and maybe other names in local agencies. Related to that, you can use pavement irregularity to calm traffic, basically sending the message something is different here. There's a different pavement texture. Usually it's very obvious that something is different and that the driver should pay closer attention, particularly to mixing of other modes. Maybe there's a higher prevalence of pedestrians or bicyclists expected in this area. This is an example in downtown Durham with different pavement textures and colors. And this is one in Statesville, North Carolina, in their downtown. And drivers should notice that there's something different with this intersection. Again, the colors and the textures are different here. And like our other examples, Kaplan Drive does have a raised intersection that does have also different textures with it. So again, a mixture of treatments were applied to this roadway segment, and a fairly short segment with a lot of different treatments. A new type of vertical combined with a horizontal element was recently presented in the ITE journal, referred to as a speed kidney because of its shape. And there are several ways this could be driven. It could be driven with one set of wheels that drives up on the vertical element. The driver could also try to straddle the curved portion without having to drive it vertically, but would still likely slow down the vehicle to make that type of maneuver. Or the vehicle could drive it on a curved path to try to avoid the vertical components of the speed kidney. So this is again a new idea, and maybe There are other new ideas that you may have that can help with traffic calming or implementing some of these known elements to a new location that hasn't had one before. When we're looking at vertical elements, we have to be very careful about the spacing of those slow points. This graph shows the relationship between the spacing of slow points, so how far between consecutive slow points, meaning speed humps or speed bumps or other, and the 85th percentile speed at the midpoint between those slow points. And so as you would expect, if the slow points are close together, the speeds at the midpoint between them is much lower. As you space the slow points further and further apart, drivers have a tendency to speed up and sometimes even going faster than they were without the slow points there, in effect to try to make up time that they consider being lost for slowing down for the slow points. There are other design elements. Parking is one, using parallel or angle or back end parking, again just creating that friction on the vehicles. Adding a bicycle lane, which can also be part of a road diet, which is a 4-lane to 3-lane conversion. Typically, turning one-way streets into two-way streets calms the traffic, usually results in lower speed, so that conversion can have the desired effect. And also another option is just to reduce the delay on arterials. So if you want to encourage drivers to leave neighborhoods, leave local streets, if arterials are improved, maybe signal timing, maybe it's a capacity issue, you may be able to divert drivers out of local streets and onto the arterial network, which may be a more appropriate place for them to be to begin with. So we have some design guidance on parking, median islands, some of the dimensions required for curbside parking or head-in or back-in diagonal parking. So it's also important to consider how the speeds and volumes will be impacted by a particular design. So looking at a couple of these treatments, this one with restricting entering traffic had a substantial effect both on the speed and on the volume. The speed humps had some effect, reducing the speed somewhat and having somewhat of a volume effect. So again, the thing we've got to think about though is making sure we likely did not just lose these vehicles. They didn't just stay home. They're likely on other routes. So we've got to be careful that we didn't just move our problem to the next adjacent street. A little more details on the speeds between slow points for different treatments. So looking at the change in speed, you can see the smaller humps, or the more abrupt humps, looks like those have a larger effect in reducing the speeds than tables and narrowings, half closures, or diverters, but all of them appear to have the desired decrease in speeds from the before to the after. It may also be interesting to look at the actual speed profiles. So the highest line here is the 85th percentile speed before the 14-foot hump was installed. So that's around 32 miles per hour. The 50th percentile speed is the solid red line, which is at about 26 miles per hour. In the after, the 85th percentile speed, even at the portions 500 feet before the speed bump, were substantially lower than the 85th percentile and the before. And you can see at the point where the speed hump is located, that's at 0 on the x-axis. The 85th percentile speed drops down to 21 miles per hour, and then drivers will speed back up, but still substantially below the 85th percentile speed before the treatment. We see a similar shape to the 50th percentile speeds. And this is the same type of information for a 22-foot table. Both of these were from the city of Portland. But in this table, the speed table, there was less of a pronounced effect on speed, so more of a gradual slowing and then speeding back up compared to the more abrupt speed hump in the previous graph. It may also be important to consider the volume impact. So the previous information was focused on speeds. How also are the volumes affected? And so we can see with the introduction of these treatments, the volume decreased, some more substantially than others. And the reason for this can be the location. So in this image here, southeast 63rd Street, the speed change was fairly substantial, but the volumes actually did not change. And that's likely because if you look at 63rd Street, which is kind of the main arterial or main collector through this neighborhood area, you can see there really are not many alternatives. But if you look at the image on the right, looking at 166th and 162nd Avenues, 162nd has the speed humps installed on it, and with 166th Street being a reasonable alternative. So basically the volumes there decreased substantially from 1472 to 1071. So likely that additional traffic shifted over to the adjacent route. In terms of collisions, the international experience has shown substantial savings in terms of collisions with a variety of these traffic calming measures, from chicanes at 82% reduction in collisions, up to, in this graph, showing one of the less effective but still an effective collision reduction factor related to speed limit reductions of 30%. In the U.S., there have been changes seen in the number of collisions with some of these treatments. A lot of the more substantial collision savings were found in Seattle, so excluding those overall with this mixture of treatments, there was a 25% reduction in collisions. But that information can be somewhat misleading because, as you would expect, if you can discourage people from using the route, meaning the volume goes down, you're likely to see fewer collisions. So if you actually consider the traffic diversion, the crash reduction was 27%, and the actual crash rate, so the rate of crashes, was down 4% with the sites included in the study. So looking at British versus U.S. installation, there was a change in speed for these vertical elements that was much more substantial in Britain than in the U.S. And for the sites included in this study, there was actually an increase in collisions in the U.S. Likely those were probably rear-end collisions for people misjudging the speed changes from the vehicle in front of them, where the British experience saw a reduction in collisions of 57%. We, as a public agency, particularly a local agency, it's important to work with the interest groups, the stakeholders, and some of these may be for or against the traffic calming measures. These stakeholders include residents, and maybe on the opposite side, cut-through drivers, so the drivers trying to cut through the neighborhood. You may think about the drivers on the arterials, truck drivers, transit and other system service operators, businesses, law enforcement, fire and emergency responders, city council, other local elected officials, staff with the city. All these groups may have their own perspectives, may be for or against the traffic calming measure, so it may be important to help them understand what the the need is for the traffic calming measures and what the plan is for installing them. One of the big concerns with traffic calming measures, particularly vertical elements, is emergency response time. So a study was done to try to measure the effect of speed humps on emergency response times. Typically, critics cite the delay as 30 seconds per hump, but in this study, the delay per slow point was approximately 10 seconds. So depending on the number of slow points, 10 seconds per slow point, that may or may not have a large effect on the overall emergency response time. Implementation for any civil engineering project is important. Traffic calming is no different, and it's a process that needs to be undertaken, starting with the identification of the problems, and that could take the form of speed studies and traffic counts, crash analyses, or maybe other special studies relevant to that particular area. A consideration for alternatives for traffic calming measures, and the selection of one that is capable of solving the problems. So if the identification of traffic problems finds one type of problem, the alternative should be focused on actually solving that problem. Following that, there should be a prioritization of projects based on the funding that's available on some objective basis. Then the installation of measures on a trial basis, subject to the follow-up performance evaluation. And in terms of a trial basis, this may take the form of, there are 10 locations that this treatment may work in. Maybe we start with one, or it could be actually installing some temporary traffic calming measures before a permanent installation is put in place. And then documentation of the entire process is very important in case of litigation, or just so lessons learned can be documented and applied to future installations. From a local agency perspective, a process for public requests can be very beneficial. So making sure there's some process that residents can follow to help manage the requests that come in. So one way to do that is to have a formal request from citizens, so a formal process. Maybe it's just one page that asks for location, a problem description, which could include the time of day or day of week, and some contact information so a follow-up can be made. This step in itself likely will decrease the demand for these. So if someone calls and has a complaint, you can give them a productive outlet, but they may not be serious enough about it to actually follow through and provide the necessary details. After the study is completed, if no problem exists, it could be useful to share data on pedestrian safety with the neighborhood groups, maybe deploy a mobile speed radar to help appease residents. That way the residents can monitor the speeds, maybe report back to city engineers, possibly work with law enforcement officers to send letters to speeders. But then if a problem exists, it's important to gain consensus from the neighborhood, maybe through a petition, holding public meetings, testing planned treatments with temporary devices, so using paint and cones and barrels before actual horizontal features are installed, and then installing the planned treatment if that test was successful and had the desired impact. This is an example in Cary of a mobile speed unit. This is one that's a relatively easy one to install. It's just installed on an existing utility pole directly beneath a speed limit sign. The City of Raleigh has a formal process that allows people to request a residential speed reduction, a multi-way stop request, or a traffic calming request by giving their contact information and a description of the location and request. So the City of Raleigh also has some information One of their first strategies they say they'll consider is a reduction in the posted speed limit. Speed limit reductions to 25 miles per hour can be considered on local streets carrying less than 4,000 vehicles per day, but a petition is needed with at least 75% of adult residents or the property owners along the street. And if that petition is received with that level of support from the community, the staff will prepare a request for the city council. If the city council approves, new signs will be installed that reflect the change in the speed limit within 1 week. They also have some information about multi-way stops used for the purpose of reducing speeding on a street. And they also mention importantly that while a stop sign is effective for controlling traffic, the reality is that drivers will often speed up to make up for that lost time, and it's really not an effective measure in terms of reducing speeds, and may actually make the problem worse in the long term. This is a more detailed traffic complaint form from the town of Poughkeepsie, just getting more information and additional details from the resident that has a complaint related to traffic. The margin of approval is important. So we saw the city of Raleigh does 75%. That's more in the kind of super majority. A simple majority would just be 51% of the community supporting the traffic calming. In a survey of public agencies, the median approval requirement was 2/3, with a range from 51% to 80%. And the support likely varies depending on who you ask. So residents on the street that would get the traffic calming likely have a high approval of that traffic calming because they want the traffic in front of their house to be calmed, whereas residents on adjacent streets likely do not support the traffic calming because they're going to expect that traffic is going to come or be diverted onto their street. So the scope of that petition is very important. It depends on who you ask, and if you're going to ask those who will be affected by the potential traffic calming measures. And so what the city of Portland has in place is to look at non-project streets and see and measure those and make sure there's not an unacceptable increase in traffic volume. So essentially their baseline, which is shown here, the middle line, looks at a maximum, depending on the existing vehicles per day, but a maximum acceptable increase of 400 vehicles per day. The other two lines are that range of variability just in the nature of traffic counts, may be higher or lower on the particular day that the study is undertaken. So to summarize the traffic calming process, it's essentially a well-accepted retrofit. There are lots of alternatives. We talked through some of them, but there are more that exist. It is important to have a plan, an involvement process, and very clear objectives if you're going to undertake traffic calming measures. And it's very important to consider the system-wide effect. So looking at not only on that local street, but what effect it may have on other adjacent streets. And overall, the advantages you may see from traffic calming include reductions in speeds, reductions in the number and severity of collisions, encouraging walking and bicycling, reducing the dominance of vehicles, and increasing the sense of community by decreasing community severance, particularly if a higher speed, higher volume road is in the area, or speeds are higher than what the context would suggest. Some of the disadvantages, though, of traffic calming could be discomfort from drivers and passengers, particularly for some of the vertical elements, potential to cause damage to vehicles. These treatments likely increase maintenance cost, so adding the complexity there with the design and construction, and then likely with the follow-up maintenance. It can increase emergency vehicle and transit travel times, as well as noise and emission. So the more decelerating and accelerating is likely to increase those noise effects and the potential for the emission effects as well.